This video demonstrates the determining the Laplace transform of full wave rectifier waveform using waveform synthesis. So this is the full wave rectifier waveform. Yeah. By observing this waveform, this x-axis is the time and y-axis is its magnitude. Its magnitude in this case is 1 unit. And coming to the x-axis, time is 0, 1, 2, 3, 4, like 4 units. Up to that we have taken. Again, it will be go on repetitive one. And if we are observing this 0 to 1 and 1 to 2, 2 to 3, 3 to 4, so it is a repetitive one. So it is a periodic one. It is a periodic one. If we determine the Laplace transform of one cycle, then we can easily estimate the Laplace transform of the complete waveform. So consider the first cycle. Its duration is 0 to 1. Its duration is a 0 to 1, one complete cycle. We know the Laplace transform of the sinusoidal signal. This is the Laplace transform. It is a one sinusoidal signal. It is started at 0. And another one waveform, it is started at a time 1, that is delayed by a 1 unit time. When we add these two, the negative of this cycle and positive of this cycle will be gets cancelled. Similarly, positive, negative, like that, it will be entire waveform will be get cancelled. We are getting the one cycle. So we are getting the only one cycle. And this will be the cycle duration is 0 to 2. And this will be delayed by a 1 unit time. Both have a same magnitude. So when we add these two, we are getting this one. So if we determine the Laplace transform of the cycle 1 and shifted version of the same cycle, then we can easily estimate the Laplace transform of this single cycle. This cycle duration is 0 to 2. Sinusoidal signal has a one cycle duration of 2 units. Then omega is equal to 2 pi f, where f is the one cycle duration, that is 1 by t. That is in this case, its duration is 2, 1 by 2. Then this 2 will be get cancelled, pi. This is the omega value. And the Laplace transform of sin omega t is omega divided by s square plus omega square. And in this case, so one is sin pi t, another one is shifted by a time unit 1 unit, sin pi t and sin pi of t minus 1. So this minus 1 is shifted version of this waveform. When we are adding these two, we are getting a one single cycle. Omega in this case, it is a pi t, sin omega t. In this case, omega is pi, and this one is a t minus 1 shifted version. And Laplace transform of this pi t is pi divided by, as per this formula, s square plus omega square, pi divided by s square plus omega square into, because it is shifted by a 1 unit time, e to the power of minus ts, t value is 1s. And when we taken this as a common factor, pi divided by s square, so 1 plus e to the power of minus. Only we determine the Laplace transform of the only one cycle. But we have to determine the entire waveform. We determined only one cycle, but the waveform, this will be a repetitive one. It is a periodic one. The Laplace transform of such a periodic waveform is f of s is f1 of s divided by 1 minus e to the power of minus ts. T value is 1 unit. 1 divided by 1 minus e to the power of minus s. And whatever we determine the Laplace transform of one cycle, that is pi divided by s square plus pi square, that is into 1 plus e to the power of minus s.